All right, hello everyone. We are about to get started. To quickly introduce myself, I'm Jake. I'm one of the product marketing managers for Noir, and I'm very excited to start this debate. Our goal initially was to have a very formalized Oxford-style debate, but as you'll see, we'll make some slight adjustments to it. We will still begin with some opening statements from each of these lovely people. With us, we have Joe Andrews, one of the co-founders of Aztec, and we have Maya Dotan, one of the product managers from StarkWare. So with that, I'll let you guys introduce yourselves and take some opening.
Thanks for being here. I think this is our third official NoirCon. There was a 0, so off by 1 error for NoirCon. I'm one of the co-founders of Aztec. We've been kind of working on privacy tech for the last 7 odd years. Noir's been around for kind of 4 years, so it's amazing to see where it's got to, and so many different people using it. I think my side of kind of what I'm going to be arguing for today is just around maybe some education on why privacy needs to be by default. And I was kind of thinking about this morning, and there's 3 kind of main reasons that we think of why you need privacy by default. The first one is kind of around secrets. This is not going to be technical, but if we just do an example of a secret, if I tell everyone here that I'm Joe, I was born in 1991, and I'm 34, I can't take that back, right? That's something I've shared with you privately, some private information I've shared with you, but I can't remake that private for this room. And public blockchains are kind of the same sort of thing. Like if you have a balance on a wallet, you can't suddenly encrypt that. So there's this kind of, issue that we have where secrets are no longer secret when you share them. And so the first kind of reason that you have to have a system that's private by default is just, it's around secrets and not being able to re-encrypt a secret. So that's kind of the first reason why for Aztec and Noir, everything starts as being private. The second reason is mostly around anonymity sets. Absolute privacy is not that useful. If I kind of came here to this debate and kind of in protest just sat here in silence, like privacy by default, I'd probably lose, and it wouldn't be very exciting for anyone in the audience. So whenever you interact with people, you have to reveal some privacy. You have to give up some privacy. Some people call that selective disclosure. But every time you do that, there's like a little trace that's attached to your digital identity. And the group of people that trace could have come from is very, if it's small, then you have no privacy, right? If I do an example and say, I'm the only person, I'm also born in England when I share that secret, you can kind of look at the stage and be like, it doesn't matter like that there were initially 3 people, the person who revealed all those secrets is Joe. And so the privacy set really matters for when you're kind of revealing secrets. And so if you're private by default, it doesn't mean you have a large privacy set, but it's optimizing to try and get the largest privacy set. If you have kind of, app-specific privacy, the privacy of kind of a single app, it can be linked across multiple apps, and with statistical analysis, you can quite easily, normally see through it. And we saw that on kind of Ethereum with various kind of like privacy tools and mixers. Like many kind of chain analysis tools could actually just link them together, and so could exchanges. So it's not the strongest form of privacy. And the third one, I think we'd all agree on is just around what does privacy by default actually mean? It's not the network being private. It's that privacy has to be at the source, and that really means client-side proving. So if you think about kind of WhatsApp and Telegram, or well, not Telegram actually, that's very not private, Signal, when you send messages on those platforms, it's encrypted at source. And so the network actually, it shouldn't matter. The privacy by default comes from privacy on the client side. And so, we've been working, like many people here, on trying to get proof systems that work in the browser. And that's the best way to get privacy by default. Kind of the 3 main reasons we advocate for it with Noir and Aztec. So that's, my opening statement.
Okay. So hi, I'm Maya. I'm a PM for all things proving and privacy related at StarkWare. So StarkWare is a proving-focused company. We've been around for, I think, also 7, maybe 8 years now. I haven't been there all that time, but and the premise that StarkWare was founded on is that proving is useful for scaling. So at first, we were not very focused on the privacy aspect of things. And I think that we have shown a very strong use case for scaling. And we are the team that maintains StarkNet, which is a very performant layer 2 ZK rollup over Ethereum. And the word ZK here is kind of charged. But we have recently been focusing more and more on privacy use cases and specifically client-side applications. So our new Provers 2, StarkNet 2, is much faster, and we aim to release a very, very fast and usable, I want to say, client-side version. We have an alpha out, but it's supposed to be better by about 50x, hopefully over the next year. And we also are going to make 2 ZK. So Stark provers are typically not ZK by default, as opposed to Snark. So it takes some more work, but we know what we have to do to make it work. It's not that much work, so it's on our roadmap, hopefully by the end of the year, if not by the beginning of next year. We really at StarkNet want to focus on privacy apps that are usable to the end user, and this, I think, has several different things to focus on. The first one is, I want to say that end users typically do not understand privacy and do not understand security, and they shouldn't. It should be something that's taken care of for users. And it should be by default in the sense that even if the network is not private by default, which it should be probably, but even if the network is not, the applications facing the user should be, and hopefully all information should be retained on client side, proven on client side. So at least when it gets to the blockchain, it's anonymized to in the sense that beyond some statistical analysis that's hopefully obfuscated by large privacy sets, then not much is leaked. Privacy is, is not well defined. There's zero knowledge privacy, there's differential privacy, there's statistical privacy, there's all these senses of privacy, and of course, users shouldn't be able, shouldn't have to differentiate between them. They should just know that people can't steal their private information. The same goes for security. So people by default assume that their money would just not get stolen, and they don't think about the case that the system they're using is not secure. This is true both for blockchain system and for regular systems like KYC and all these systems that just leak information all the time, banking data. So, and the second thing I want to say about this is that we believe strongly that most users in the world want a combination of privacy by default with compliance by default. So we are focusing very much on generating libraries for users, and when I say users, I mean applications, to develop privacy by default and compliance included by default to comply with laws that match the regulation of their choice easily. So, because we want to bring on board previously, like sectors that previously have been skeptical about blockchains, and we want to make that transition very smooth for them, and for them not to have to worry about some regulatory entity somewhere in the world coming up and saying that like they're in trouble, or that even like they're questioning what they're doing. We just want to and we believe that end users care about this. They don't really care, like, unless they're trying to launder money. They just want things to work, and they want to never think about things that can go wrong.
Yeah, I fully agree with that. I think, like in the kind of identity space, like there's a lot of kind of, I guess, FUD in the Web 2 world of like what people put up with in terms of giving their ID out. And there's a tension around kind of the types of proving systems we have today and like Web 2 cryptography. Like it's fine to kind of be like, hey, we can do a Poseidon hash, or we can do this like, you know, like a very small Schnorr signature, and we can make it ZK. We kind of had that like 3-4 years ago, and we didn't get adoption, like quite frankly. Like to get adoption in the real world, you have to do exactly that. You have to go and meet Web 2 where it is. And I think the ZK Passport team is maybe here later, but they're verifying like RSA 4096 signatures with like a SHA-512 hash. Like it's so horrible, like in terms of like what you need to do in a proving system. And so, yeah, I think that users don't care about that, right? But you need to have an underlying tech stack that lets them do that client side and, you know, on their devices. Otherwise, you're just offloading the same passport data to a server, and you haven't really solved anything compared to taking a picture of your ID and giving it on Fido to leak it to someone in 2 years. So yeah, I think there's still problems, but I agree with kind of like users not wanting to make the choices about their privacy, and I think, yeah, that's why we go for kind of privacy by default. I'd love to hear more about like the kind of client side stuff. Should we go there, or do you have some questions?
Yeah. No, we can go to client side. I mean, it sounds like there's a lot of agreement. Privacy is great to be able to add. Of course, we also need the option for things to exist in public. Otherwise, we're sitting silent in a room, like Joe said. But yeah. Maya, did you want to say something?
Yeah, so I think client-side proving is useful for privacy, both in the sense, like the classical sense that everybody thinks about, like ZK Passport, ZK applications on client side for privacy. This is a clear path for privacy. But I feel like there's also a lot of proving applications for privacy on the client side that don't have to do necessarily with the ZK property, but like with a proving property. So imagine like, a huge security risk in the world today is IoT devices, right? So, and basically they're manufactured in China. You don't know where they're sending information. They're super hackable. There's no standards that are even like remotely viable in any other context. And they control your home. They control your car. They control like your cameras. Like basically they leak all things that you hold intimate and private. And you can just not have that happen if you use client-side proving. For instance, you can have a very, very simple circuit on an IoT device that just proves that it's communicating with a single IP address and it's yours.
Is this you saying that StarkNet will start selling Philips Hue smart bulbs?
No, so StarkNet is not developing client-side applications. StarkNet is a network, and people are working to use both the technology, which is open source, and hopefully also the network, but blockchain. But we are very, very excited to see the vision that StarkNet and StarkWare were founded on, that proving is a means to return power to the end user.
I think, yeah, like I actually moved into a new flat, and the old owner left like a doorbell from some make I'd never heard of, and I was like, this is literally taking a picture of me every day, and where's it going? So I think that's a great analogy. I think one thing that, like I said, NoirCon, like, how do you think about kind of like writing applications for privacy versus applications that have public state? Because one of the main reasons we kind of like had to build Noir all those years ago is we were writing circuits in C++. It was impossible to debug. Zach, I don't know if he's here still, was the only one who could do it, and we basically, it just became like a huge bottleneck. And so Noir came about because it was like, hey, if we could build this, front-end language that, more people could pick up and was familiar, and it was kind of back-end agnostic, we could get more people into the space, which I think we started to see, which is great. But is the kind of plan then for these like applications to have them written in Cairo, or that's just for StarkNet itself? Like how do you think about how you would like actually execute on this? Because I know we've got like a Noir verifier for StarkNet, but is that orthogonal, or how do you think about that?
So, okay, there's a few questions entangled there. So, Cairo is the language that StarkNet is built on. the chain of events is we have a prover, we had the Stone prover, the StarkNet 1 prover. On top of that, we had the Cairo VM, which compiles to Cairo machine code, CASM, and that is super easy to prove. So, and Cairo is a high-level language that's designed to compile down to CASM code. So, so the entire flow is that a user can write in high level, hopefully Rust-like syntax, and it compiles automatically, and you don't even have to think about it, and you get code that's provable, and it's proven, and everything works. And this works perfect for StarkNet, because smart contracts, it's also a smart contract language, and with Sierra, you also have completeness, which is super important in the blockchain context. So kind of the entire flow for having a provable blockchain and blockchain language works really good with Cairo. However, at the first iteration with Stone, things were not good enough to prove things on the client side. Even small programs, it was very, very difficult to use Stone. And when we approach the next iteration of proving on our end with Stu, the new prover, we want to, so StarkNet will, to remain consistent and backwards compatible, everything will remain in Cairo. But we'll release a client-side variant of Cairo, which the name is not final. The Kakarot team is also working on this with us. Currently the name is Cairo M for M31, or in Mersenfield. It will be a Cairo-like language. It will have very similar syntax to Cairo 0. It will compile to a new Cairo virtual machine, which is much lighter, with entirely new heirs. So now we have heirs for Stu Cairo, the big Cairo, for StarkNet. So StarkNet is proven it's Stu. But we'll have new heirs that are already written for the small variant of Cairo. And that will be super fast for client-side applications. And the hope is to put a verifier for this language on top of StarkNet. So people will be able to just write code in this Cairo variant, prove their applications client-side. Hopefully by that time, Stu will also be ZK. And then you can just have the on-chain part, if you want an on-chain part to your program, in Cairo, on the big Cairo, on StarkNet, and everything works. Additionally, as you said, you can already today write Noir code, auto-compile Cairo smart contract and verifier for your Noir program, and just deploy it on StarkNet as a smart contract, and you can basically just prove in Noir and verify on-chain in StarkNet, super cheap. And we're very happy with this. The SDK is called Garaga, if anyone wants to take a look at this. And we're very happy about this, both because we really like Noir. It's a nice language and people really like it. And we like having the option to use snarks on StarkNet, both for the diversity of technology, decentralization of ideas and all of this, and both because we don't want to block users that want to use a different technology from using StarkNet. Yeah.
Yeah, I mean, I think like the point like if you go back to privacy by default, so the way that like Noir works for those who don't know is that like you have to declare something as public even within the program, and so privacy by default means that like a default Noir program like doesn't reveal any information, which is a very different programming model to like the Cairo programming model, and so like how like is that not a better way to do things and have Noir be proven, a backend to Noir be Sto versus like having another language? Like, because it depends what you're trying to do, right? If you're just doing public client-side proving, maybe you can do that in any language. But if you're trying to hide or disclose secrets, like aren't the patterns that like the Noir community's been building like the better way to do that? Like, how do you think about that?
I don't know about, it's hard to say what's better or worse, but I think clearly there is a demand for Noir technology, and clearly there's tooling and people want to use it, and it's privacy by default and it works, and like we're not going to stand in the way of people who want to adopt a technology that works for them. We plan on making Stu for client-side zero knowledge, so you then would have also privacy by default. I want to say that when people say privacy by default, you still have to be smart about what you're doing. Like, you can leak privacy even everything is ZK.
It's very easy to leak
Yeah.
privacy.
But privacy by default is kind of a scary thing for me.
Yeah.
But I don't think anything can be worse by having more options out there.
That's fair. Yeah. Any more questions?
Yeah. I mean, so one more question would be, when you guys are approaching Maya client-side proving, what does it actually mean to take the StarkNet chain and add on this additional piece of client-side proving? And how does that piece of client-side proving enable privacy? I know it's generally used to enable scale, but Aztec and StarkNet both approach the world of proving from the client side. Like, both require that. So I guess I'm just curious, like, what does it mean to take this piece and say, I'm going to send all this data, or I'm going to let the user handle their own data, generate their own proofs, and then like, what is the actual flow for selecting, I would now like this to be private, or I'd like this to be public?
Okay, so again, several components, I think, to this question. So the flow that we have in mind is that you will be able to prove, whether you care about privacy or not, you'll be able to run your program locally, and you run the prover locally, and then you have a proof that you ran your program. The proof, because to a ZK, will abstract away your inputs. I don't know to say whether we'll have public and private inputs. Like, we haven't had this design talk yet, but the users will be able to abstract away any inputs.
And I would be doing this as a user
Yeah.
of an application, not as like an application on behalf of a user, necessarily.
I can't hear it.
Would I be doing this as a user myself? Like, I want to go and use some DeFi protocol. This is an application.
No. In my view, a user should never have to think about what is private. Like, end users, typical end users cannot comprehend the notion of maintaining privacy. And it's not because of a lack of intelligence. It's just the world that we live in today. People do not think about privacy, and they assume that they have it. And if you change the groundwork that is under what they use, they don't know about it. So you can't just assume they'll be like, oh, now it's on the blockchain, so now I have to think about which inputs are private. Clearly, no. The application developer will have to take care of this, and hopefully there'll be also regulatory guidelines to what you have to do.
And Joe, is Aztec opposed to this?
No, not at all. I think the way I think about it is like a user can't be. It's not that users don't understand. It's that the enemy is like a statistical AI machine learning algorithm that is just going to be able to aggregate your data in a way you can't comprehend. And so privacy is not something you lose in one action. You leak it slowly over time, like every cookie thing that you click, every tiny transaction. And it's like each one of them is not necessarily bad because you don't know the effect until 2 years later when someone's like, you're Joe, this is your search history, these are all the things you like. It's the profile that becomes bad. And so users don't know at the kind of point of a leakage, like what they're losing. And so I think, we agree. And the whole point of kind of Aztec is you give developers the tooling to build apps that hopefully abstract that from the user. Users still have to prove it client side, but they're just pressing send transaction. And you're trying to make that send transaction flow as amazing UX as possible. And that means it has to run in client side devices, on iPhones, Androids, and it should be as fast as possible. But that's really the property of the proof system, not kind of the language. The language is just trying to help the developer achieve their goal for their users.
Yeah, and what you asked about scale, I think, so client side is very useful for scale. By the way, we already now have an on StarkNet stone verifier, and people use that for app chains and layer 3s. So for Stu, the way technically we're thinking about doing it, so there's different levels of complexity that you can take to have different kinds of performance. But the easiest thing to do would just be to add a syscall to StarkNet, which basically invokes this M31 verifier. And so you lose some performance there, but not that much. And the proving end is still very, very fast on the user side.
It's basically recursion, right? Yeah.
Yeah.
Yeah. So like the same flow on Aztec is like we use a lot of recursion. Like the proving system is heavily optimized for recursion, mostly because like there's like the normal Noir flow where you have a proof and you have public and private inputs and you decide what you reveal. That all happens client side. If you want to build like a fully programmable private network with smart contracts, you also have to have privacy from the individual smart contracts. So if smart contract A can see the state of smart contract B, then all this weird stuff can happen where like a malicious app can like emit your logs and say, well, I've got, I don't know, $1 million here, and I don't want this app to see it, but a user doesn't know that, right? And so when we think about it in kind of the Aztec context, we kind of do a similar thing, like that app chain verifier is an app smart contract, and we have to do that on the client side as well. And so the proof system that Zach and the crypto teams built is heavily optimized for doing that recursive verification as quickly as possible, so you can hide the state of one application from another one, but still, as a user, do everything client side. And so the flows are similar, but like I guess a little more complicated because we're also trying to hide the state of contracts and have like a contract framework to get composability.
Yeah, so true. I think with Stu, hopefully, we'll have to have, we could have something quite similar to what you're describing, because you could have basically all of the logics of a transaction run off-chain and then just verify a state for a user that can be quite complex. Like for trading, like you can have a DeFi platform that most of the logic runs on the client side, then maybe some other additional proofs on the operator side, then everything is settled to the L2 and then nothing is leaked. We do use recursion heavily also for efficiency at StarkWare. So in Sharp, we use recursion to lower L1 costs for users when you settle on Ethereum. And it will be crucial for Bitcoin as well when we settle on Bitcoin, hopefully with OPCat. But yeah, recursion is, I think, like no proof system, no company that seriously is into proving now can ignore recursion. Yeah.
Got it. Yeah, that's been really helpful so far. Unfortunately, we're nearing the end of time, but would love if you guys would take maybe a minute or two each. If there's anything you want to close on, anything you want to plug. Yeah.
Maybe I'll use my closing statement to ask a question. Like, what's needed to get a new backend for Noir with the Stow prover?
So Kakarot, who is working with us, took a look at the compilation of like the option to just like natively compile Noir with Stu as a backend. It seems rather straightforward from what they said. I didn't look at it personally, so I just don't want to commit to anything. But they said it shouldn't be just too hard. Just like compile your code.
Maybe there's a NRG 5, and we can get a grant going for another backend. I don't know. I guess like my conclusion is kind of, I think there's a lot of similar thoughts here. Like for us, privacy needs to be by default. You can't unshare a secret, and client-side proving is kind of one of the tools we have to get there. We're actually kind of like back-end agnostic, even in Aztec. We use Bredenberg because it's the fastest one that works for what we do right now. But long-term, if someone could build a better one and it works with Noir, we would switch. That's kind of the design choice we've made. But I think we need to see the benchmarks and go from there.
Yeah. So. I'll conclude by saying that we are meant to release the Stu benchmarks, like the big Cairo Stu benchmarks this week, hopefully next week. It's at the end of the week now. And check it out. There's a client-side version alpha out there. It still operates over the big Cairo, over the big field, but it's still far more performant than every other Stark system, and also Jolt. But we haven't compared against Aztec, so we should.
So will you benchmark against Bredenberg?
Yeah.
Let's do it. That's a good conclusion.
Awesome.
Let the numbers win.
Awesome. Well, thank you guys very much. Yeah.